Hello, my name is Yusha Bey. I'm part of the engineering staff at CNM2. I'm here to create the operations training video for we call it the Technics, that's the tool ID in Badger. However, in reality, it's the Plasma Equipment Technical Service, RIE. This is a parallel plate etcher. Has 4 processed gases available to it. Sulfur hexafluoride, CF4, N2, and oxygen. People typically will process, this is where we do our dirty processing, but people typically use this for plasma ashing, just using O2 plasma to burn off a residual layer of photoresist. People use this to activate wafers for wafer bonding, and sometimes people will do selective etching of silicon using the CF4 or SF6. Now to begin with the tool operation, first step is always to log in the Badger. Again, the tool, it will be under the etching category, and tool ID is Technics RIE. When you come to the tool, you always want to fill out the log books. Probably bring it up to the camera, like so. You want to put your name, PI, date, substrate, and the parameters of your etch, like what gas you use, what your flow rates, your power, pressure, and duration of the etch, and also any comments you may have, if you've seen anything irregular or if everything worked out fine. Additionally, always remember, if you do see something abnormal with the tool, to log that under the comments or problem section in Badger. All right, we have the log book filled out. Okay, so when you first approach the tool, it'll be under vacuum. And we do this to keep the chamber particle free and moisture free. And every time you exit a session, we will also be pumping the tool back down to vacuum. So when we, to load a sample, first thing you need to do is to close the vacuum valve, and then you want to vent the chamber of nitrogen. The vacuum valve is right here where my cursor, mouse cursor is. Also, you see here that this is a manometer for the process pressure, process chamber pressure. Then also here, this shows the throttle valve position. When you're actually processing, you'll see different percentage values indicating where your throttle valve is in order to obtain a certain process pressure. But anyways, first thing you want to do is close this valve. So now you see that circle became an X, indicating that that valve is closed between the process chamber and the vacuum pump. Then we go up to vent. We want to open the vent because the vent will allow us to climb to atmosphere pressure a lot quicker, as opposed to allowing to leak up the pressure. Open the vent. So once you hear that hissing, which indicates that you can hear the nitrogen flowing, that means the chamber is open. The chamber is pretty small, so I would say it opens in probably, or it comes to atmosphere in probably like 5 to 10 seconds. Open the lid. Now you can really hear the vent, the nitrogen vent. You see that we have a like 12-inch platen. Typically can hold 3 4-inch wafers, several dies, of course, 1 6-inch wafer. And see, this is our free-for-all chamber, so pretty much every material is allowed in here. We load our dies, close our chamber, come back to the computer, go back to the vent icon, close the vent valve, then we want to open the vacuum valve. So now our chamber will begin its descent to 20 millitorr, 15 millitorr range, back to our base pressure. And base pressure, by the way, means the lowest pressure that the vacuum chamber can achieve. And also, I guess, depending on what you're doing, so you may not have to wait for base pressure. If you're just doing simple plasma ash, like you just finished lithography, and now you want to just remove that residual, like, mono layer of organic, whether it be from the water or whether it be from your photoresist or your developer, you would just start processing right away. As opposed to a selective etch where you want to etch silicon or a nitride or an oxide, you probably wait a little longer. You probably want to make sure that the vacuum is as high as it possibly can be. So once we reach our base pressure, see we're in the teens now, we're going to go ahead and set our flow rate for our oxygen gas. And for this example, I'm just going to do a basic standard oxygen plasma that people have been using in the Cnum 2 clean room. So to change our set point, we have to use the scroll bar here. Unfortunately, the intuition would tell you just to type the value in. However, the software, the application lacks that type of sophistication. So we're going to have to use the scroll bar to put in our set point. And to get further tuning, we can just press the directional pad on the keyboard to get directly to 7. Once we have our set point dialed in, we have another valve here. We want to go ahead and open that valve so the oxygen starts flowing. See that this turns red. However, it'll settle out and reach 7. Also, you see this process chamber icon now has this kind of blue dashed lines indicating that we have a gas flowing. Next process parameter to set will be our process pressure. Again, we have the same scroll bar, and again, for fine tuning, you'd use a keypad. We already have a value set of 215 millitorr. All the values are in torr, and I guess going back to the oxygen, to the process gas flow rates, these are all in standard cubic centimeters or SCCM. So going back to our regulation, we already have the value set. So to engage the regulation meaning the throttle valve, which will control the pressure in the process chamber, we just press this off button. Now it turns on. And now we also see our sensor that tells us the status of the throttle valve is now actively moving around. After setting the process chamber pressure, we want to set our plasma power. Very key thing to note that this value here does not represent a wattage. It's not 32 watts. This value represents the percentage of power that our power supply can deliver. And camera can pan down. Our power supply is on the floor. But you'll never have to interact with that directly. Everything is remotely controlled from the software. So our power supply can deliver 675 watts. Standard recipe for plasma ashing is 200 watts. So we need about 32%. Again, it's another scroll bar. You can use directional pad for fine tuning. Now that's set. Now to monitor time, you can use a handheld stopwatch, or you can use this little stopwatch application. I personally use a little stopwatch because I can stopwatch in one hand and I have the mouse in one hand. I can immediately turn off my plasma right when I want it, as opposed to fiddling around with the mouse because you got to stop it here. Or I guess you start your time here, then you come over here, so you have a few second delay, but no big deal. It's all personal preference. So you have two modes. You have a stopwatch mode or you have an elapsed time mode. If I press start here, it'll just start counting up to like 99.99. I can stop it here. I can clear my values with these arrows on the side. Then I can do my stopwatch mode. I can set a time, like 15 seconds. Press start. So again, these are not integrated at all. This will just count down, and this plasma will just keep burning until I turn off the power supply by pressing the enable disable switch right here. So I'm going to go ahead and start the time. I'm going to go ahead and turn on the plasma. So now we have a plasma in the chamber. You see that is not that nice white blue we're expecting for oxygen. However, because this port cover is heavily contaminated with previous processing, that is contributing to this different color. Okay, so we did about 15 seconds. So now to end our process, we want to go in reverse order. You want to always turn your power off first. Then we want to go to our regulation. want to hit that on button, becomes off. And then we go to our process gas and we close the valve there. And now we allow our chamber to go back down to the base pressure. So if you're working on something that may have particularly hazardous byproducts, you will want to do this next step, which is the pump purge sequence, where we pump the chamber down, we close the valve to the vacuum pump, and then we purge briefly with nitrogen. And then we do that 3 times to help get those byproducts out of the chamber and into the vacuum line and exhaust it out. So let's consider that first pump down to be our first pump. We close the valve to the vacuum, come over to vent briefly, close it, pump. So that's, pump purge 1, and we'll do it a few more times. Or let it pump down a little longer. Pump, purge, close purge, pump down. We go a little lower. Get down to the base pressure value, a little closer to that. This will be the final one. Close vacuum valve, purge briefly, pump. Pump back down to a value that's close to base pressure, like 20s of millitorr. Okay, now finally I will vent the tool. Close vacuum valve, vent all the way to atmosphere. Open the chamber, take your samples out. Close the chamber, making sure the lid is centered. It can kind of wobble left and right. Come back to our software application, close the vent, and open the vacuum. Then we make any additional comments in our log notebook. If we saw anything abnormal or if the tool is malfunctioning, please contact CNM2 staff. Leave comments in the badger if anything is unusual, and we'll definitely address them. But yes, that is the operational training for the Technics RIE. Thank you for listening.